Hey, it's Bodie from Bodie Knows. Today we're talking about the K2 Plus, specifically for functional parts like this RC jet stand. Let's get right to it. Alright, so for me, the biggest pro is speed. Coming from a CR10, which was lucky to do 50 millimeters per second on a good day, the 600 millimeters max per second at the K2 is completely mind-blowing. The speed for me is important for two reasons. One, I don't have all day to sit around and wait for parts to get done. I'm typically doing things on nights and weekends, and I want to get more parts done per unit time because I have more things to do than I have time to do them. Secondly, you can actually make stronger parts when you're moving fast. So if you have less time between layer A and layer B, layer A is going to cool down less before you deposit layer B. So that means there's going to be a lower temperature differential between A and B, which means you're going to get better bonding. On the 600 millimeters per second, that's their advertised max. In reality, you're going to be flow rate limited way before you are gantry speed limited, unless you're running incredibly small layer heights, which I do not do. I previously used a 0.6 millimeter nozzle on my CR10 in an effort to go faster, but because I'm not limited by the gantry speed and only flow rate, I'm now using a 0.4 millimeter nozzle, which means I get all the benefits of the 0.4 millimeter nozzle, better precision, finer detail, and none of the drawbacks, which was speed previously. The second pro for me is the precision and repeatability, and those are two different things, and they're both a pro with this machine. So first and foremost, the parts look great. That isn't exactly important for functional parts, but it does instill some confidence that you're getting quality parts and all the internals are built properly. Fewer defects, which is the repeatability, is going to lead to fewer failures. So typically a failure in an engineering part is going to originate at a defect, whether that be on the outside or the inside. You'll have a small defect where you get a stress concentration, and then that will propagate quickly throughout the material, resulting in a failure. So fewer defects means fewer failures, which means better strength. And then for precision, mating parts fit. That's important when you're making assemblies that have multiple components that come together. You want things to be built fairly close to how you design them. You're never going to get that close with a 3D printer, and I would discourage anyone from doing any sort of calibration or offset scaling, any sort of weird stuff like that. Just drill, ream, machine, whatever you need to do to get a super high precision part. But for the most part, for general purpose test, fit, function, and actually assemblies that do go together and function properly, I've found that the precision has been more than adequate. Third pro for me is the fast heat up, both the nozzle and the build plate. So the nozzle has an 80 watt heater, and that means you can go from 70 all the way up to 300 C in like 10 to 20 seconds. Previously on my CR10, that was taking multiple minutes, especially over 250 as you had an inverse exponential curve on the temp versus time equation. The build plate has a 400 watt heater, and that gets up to 100 C or beyond very quickly, just a matter of minutes. That could take 10 to 20 minutes on the CR10. This being said, the startup time itself is a con, but the individual elements of that startup time, just the heating of the nozzle and the build plate, are a pro. Pro number 4 is a heated chamber. That was a big reason I waited so long to upgrade my printer. For those of you that know, the CR10V, whatever this is, 2 or 3, is like 5 years old, and I had been resistant to get a new printer for a long time because I was waiting for a consumer grade printer to come out with a heated chamber, and I finally got my wish with this thing. Heated chamber is important to me for engineering grade parts for two different reasons. Number one, you get stronger parts. As I said with the layer to layer bonding and the speed thing, the hotter layer A is that you're depositing layer B on, and then the resultant lower temperature differential, the better bond you're going to have between layers. And then it's fairly obvious, but you're going to have less warping in a heated chamber, meaning you have more freedom to use more materials in more ways. Pro number 5 is the software, both in terms of the machine and the slicer, which you don't necessarily have to use their slicer. The software on the machine, it's very feature packed, and that's great. I like a lot of those features. That being said, this is a pro and a con, and I'll get to the con. It can be a little buggy. When this works, it works really well. I really like the AI feature detection, so if you have a spaghetti mess or some other sort of issue, it will stop. If you put your hand in there when you shouldn't, it will generally stop. The workflow is fairly easy. There's no cables, SD cards, anything like that. It talks to a computer very easily, and again, when it is working well, especially combined with the CFS, you kind of have your own little manufacturing hub that you can run somewhat remotely from your computer, and I like that. Pro number 6 is the CFS. So For engineering type parts where you aren't going to be doing color changes, it's much less important than if you're doing multicolor parts. But for me, the biggest benefit of the CFS is being able to use multiple rolls of filament on a single part. So especially with engineering type materials, they're pretty expensive, and it sucks to throw away a spool that has 100 grams on it when you need to print a 200 gram part. So if you put two spools of the same material in, it'll switch them when one runs out fairly well. I have had a few issues with that, but in general, it's an upgrade over having no functionality. I also like, as I previously said, the whole manufacturing hub thing. You can just pick materials from your computer if you want and run things without doing a whole lot of manual material changeovers. All that being said, I'll get to it in the cons. The CFS is buggy, and I do like that the side spool over here is an option. It's very easy to change over from the CFS to the side spool. And for me, when I'm doing nylon carbon fiber or PETCF, things like that give me issues in this CFS, I generally just go straight to the side spool holder, and it works really well. Pro number 7 is the linear rails and the whole mechanical system of the machine. So both the X and the Y-axis have linear bearings. The X-axis has a linear rail, the Y-axis has linear bearings, and in general, it's very stout. It does have one major con, which I'll get to in the con, but in general, I like to see a robust mechanical system. Pro number 8 is the fans. So for engineering type parts, generally I'm not actually using fans, but I do still do a lot of PLA parts where I want quick fit and function verifications. So I print a lot of very low infill, lightweight PLA parts as fast as I can just to test things out. And having the ability to print things really fast, have really severe overhangs, long bridges, be possible with all the fans you've got, it really helps me out. So there's the model fan, which works as you'd expect. There's the side fans, one on each side, which put out a ton of air. And then there's the rear fan that ventilates the whole printer. So if you open the front, turn on the back fan, you get a pretty good amount of airflow in there, and you can pretty much dial up your temperature. So the temperature control combined with the fans gives you excellent cooling. Pro number 9 is the build plate. I've heard a lot of mixed reviews on the build plate out there on the internet, but for me, it's worked awesome. It's an issue I've run into previously when I'm doing a bunch of different functional materials, swapping materials out all the time, is different materials need different build plate conditions in order to stick well. But the build plate on the K2 for me has had zero issues. I use a watered down, a water glue slurry on the build plate, which I'll do a demo of here at the end. But for me, that's worked for every single material I've thrown at it. It's magnetic and flexible, so parts come off very easily, and overall, I'm a huge fan. All right, time for the cons, and there are quite a few, even though I do in general like the printer. So the first one is the X-axis rail attachment. So that's how the X-axis itself attaches to the two Y-axis blocks. It appears as though these are just friction fits and they're loose. I've emailed Creality about this, and they just dismissed me and told me I didn't know what I was talking about and that it wasn't an issue. Well, I beg to differ. Anything that's loose on a high-speed gantry is a major problem. That being said, I actually don't see a whole lot of defects in the prints, so there's a chance they're right, but I really don't think they are. Con number 2 is the filament change times. So if you're going to do multicolor prints, it's really not what this video is about. Something I thought I was going to do was do more multi-material prints for support interfaces. You're going to need to switch materials, but holy shit, it takes forever to switch materials. I'm absolutely mind blown how much moving around, verification, purging, movement, filament going in, filament going out. I don't know what the actual number is. It's probably something about along the lines of 30 seconds, but there is so much firmware optimization that needs to happen to make the filament change time something more realistic. Until then, I basically just don't use it because it'll blow up a print time from like an hour to 10. Con number 3 is the startup time. I previously said that the heater and the bed heat up quickly, and while that is true, the overall startup time from when you hit the button go till you actually start printing is like 2, 3, 4, 5 minutes, depending on the part, even longer for some. And I get on a more complicated machine, that might just be the nature of the beast. You know, the CR10, if you had a heated build plate and nozzle ready to go, you could hit go and be printing in about 10 seconds. But there's so much verification. The nozzle has to go purge, has to verify that nothing's there. It has to wipe itself, purge again, go measure the build plate, go back, purge, 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 back and forth, back and forth. I really don't understand what the need is for all that, and I think there's a lot of firmware verification or firmware simplification and optimization that needs to happen to cut down on that startup time. Related to startup time, and part of why the startup times can be long, is the bed leveling calibration. So this thing goes around and touches the bed with the nozzle itself, and for the most part that works well. However, it seems to lose the calibration point all the time. So I frequently have to redo my bed leveling before I start a print, otherwise my first layer really sucks. I'm wondering if that's related to my X-axis rail attachment issue. It certainly could be, because as you're applying a torque by pushing the nozzle into the bed, that interface is going to move, and that's exactly the problem. But sometimes it loses the calibration, sometimes it doesn't. Overall, it isn't a huge problem, especially after a recent firmware update. The bed calibration is significantly faster, but it just seems like an easy mistake that Creality should fix. Con number 5 is the push to connect fitting on the extruder where the Bowden tube hooks up. So if you go on Facebook, forums, wherever, you're going to see that is the biggest issue people are having, and it seems to be absolutely everywhere. So overall, just a huge whiff from Creality. It's a bummer that they aren't coming out and acknowledging that and fixing it in some way. But if you do need to take the tube out of the push to connect fitting, my tip is to take a pair of flush cutters and go around the tube and push down on the push to connect fitting and then pull up on the tube. But do not try to push from one side with your hand. You need to make sure that the entire ring on the push to connect fitting is down as far as it can be. All right, con number 6, the build plate and the chamber heater can't run at the same time. Not sure what the issue is with that. The build plate's 800 watts, the chamber heater is 400 watts, that's 1200 watts, 10 amps on a 120 volt circuit. Again, not really sure what the problem is, but you can't do it. So that means on a part where you have a high build plate temperature and a high chamber temperature, the build plate is going to heat up first while the chamber heater just does nothing, and it's going to prolong your startup time dramatically. Top that off with the next con, the heater pulls in ambient air. That's just dumb. You should recirculate the air and only heat up what you need instead of heating up cold air and putting it in the chamber. It's going to be way less efficient. But what that means is that, again, when you're starting up, the build plate is going to be heating up, and the chamber heater is just going to be pulling in ambient air that isn't heated. So it prolongs the startup time dramatically. I did try making a device that goes on the back of the printer so that the chamber heater sucks air out of one of the exhaust fans instead of just pulling in ambient air, so it does actually recirculate. It didn't seem to make that much of a difference. I don't know if there was too much resistance in the flow path or what the deal was. This all being said, the chamber does get up to temp eventually. It just takes way longer than I would like it to. That also being said, generally the chamber temperature is only going to be important once you're a little ways away from the build plate, away from the radiant and convective heat from the build plate. So it isn't the end of the world, but again, just a huge mistake that is so simple that I think Creality whiffed on. All right, last con is the CFS. So as I said before, I do like it, and when it works well, but man, it doesn't work a lot. It's always got some sort of issue that's difficult to diagnose. You got to take the whole thing apart, email Creality, go on Facebook, figure out what's going on. It's just buggy, and it's disappointing. I end up just using the side spool holder a lot, and that's okay, but I really wish they would have made this thing work a lot better. All right, so here are some tips to make better functional parts, both stronger and tougher. Number 1, maybe you heard this, maybe not, but do not use the fan, ever. No fans, no model, no chamber, no side fan, no nothing. Still air as much as possible. Yes, that is going to lead to parts not looking quite as good, but they're going to perform much better. You want the temperature differential between layer A and layer B to be as low as possible. In other words, you want the preceding layer to be as hot as possible. On that note, you also want to print as hot as you can go. In general, the upper limit of the recommended print temperature that a manufacturer gives you is going to be the temp at which the material starts essentially oozing on itself and being unable to remain structurally sound. But if you can go beyond that, especially with fiber-filled materials. So I frequently run PETCF, which has a recommended max print temp of 300 or 305 at 310, 315, even 320, and it works just great. So always go as hot as you can, and yes, you will take a small hit on the aesthetics for that, but you need to just get over the aesthetic thing. Get the chamber temp as high as you can, even for PLA, 35, 40 for PLA, 50, 55, 60 for engineering materials. You want layer A to be as hot as you can before you put layer B on top of it. That's going to give you a better bond. There's some other things going on material science-wise related to glass transition temperature, crystallization, shrinkage that are important as well. But in the context of strength, again, you want as small of a differential in temperature between A and B as you can get. Next tip, tap holes. Do not use studded inserts. Do not use heat sink inserts. I see so many people do this. With PLA, maybe, fine, but you can tap PLA. You should tap holes. Just like a metal part, you should tap a plastic part. People say, oh, you can't do that with plastic, you can't do that with filament. Yes, you can. It is different when you don't use PLA, but this is an M10 hole printed at 9 millimeters. This is an M10 tap. It's a piece of cake, and this will hold a bolt all day long, and the threads will not break first. Get over visual imperfections. When you print parts to make them as strong and tough as possible, you are going to take a hit on aesthetics. 95% of the tutorials, tips, YouTube videos out there that have recommended print settings, they're people printing cosplay helmets or little Knick Knacks to put on a shelf, random little figurines where it doesn't matter if they're strong, all you care about is making them look good. But there's a pretty inverse correlation between those tips and material strength. So really do the opposite of almost all of those and you're going to get stronger parts. Get over the cost of parts. You get what you pay for, and better materials are going to cost more money. Yes, you might spend $5 instead of $2.50 on a part. There's a limit, obviously, and I abide by it as well. At some point you start getting too expensive and I go to cheaper materials, but for the most part, better, more expensive materials are going to give you better, stronger parts. Print faster. It might be a bit counterintuitive and you may have heard go slow with engineering grade parts, but I beg to differ. I've said this a few times now, but if you print faster and there's less time between layers, you're going to get less temperature differential between layers. And in general, the temperature gradient across the part will be less severe, meaning that the shrinkage and glass transition temperature, other material science issues will be less of an issue. All right, next tip. Let's say you've got a part where you need to apply significant load in a printed Z orientation. So in this case, this is a hanger for an RC airplane. So this surface here attaches to the ceiling and then a propeller hangs across it and contacts these two surfaces. So that means you're going to have a load going in this direction that's pretty considerable, but then you also need to make sure that these portions of the part have a lot of strength. So you wouldn't want to print it like this or like this, for example, because then you're going to get a failure in here. Your best option is to print it in Z like this. What I recommend doing is put some holes down the center of this axis. So your weak point is on these cantilevered sections and you're likely to get a failure somewhere in this neighborhood. But what that hole does is it'll give you double the outer walls that you would otherwise have. So instead of having, let's say, 3 outer walls like this, you're actually going to end up with 3 times 2, 6 walls, and that's going to drastically increase your strength. Specifically for nylon, moisture condition it. So we all know materials need to be dry in order to print with them. Nylon specifically, water acts as a plasticizer for it. So a nylon part straight off the printer is actually going to be pretty stiff and pretty brittle. A lot of people will take their first nylon carbon fiber part off the printer, try to bend it and go, oh my God, it's so stiff, it's so strong. You're getting a false sense of reality. Over time, that nylon will absorb water from the air and it will plasticize it. And that plasticization is a good thing. That's what gives nylon its toughness. And the reason you have nylon carbon fiber is you have nylon for the toughness, but it isn't very rigid. The carbon fiber is rigid, but it's not very tough. So you combine those together and you get tough and rigid. The best way for me to moisture condition nylon parts is to just throw them in a pot of boiling water for 5 minutes. They'll be pretty soft when they come out, but just put them on a paper towel to let them dry and you'll get that moisture conditioning over with real quick. Always anneal parts that say to anneal them. I put them in my kitchen oven. My wife isn't very happy about that, but if you have a toaster oven or any sort of oven, doesn't really matter. Throw them in. Yes, you will get a small amount of shrinkage, and I recommend you just get over it and not worry about it, because annealing does really make the parts perform much better. I recommend putting an LED light bar on the printer somehow. I use this little fish tank light bar. The K2 does come with a small light in the corner, and I suppose that's better than nothing, but it really kind of sucks. And putting a proper LED bar makes a big difference, so you can look at your parts as they're being printed, make sure things are going the way you expect them to be. Alright, and last tip, and this is specifically for the K2, but I suppose it would apply to other printers that have a heated build chamber. Just throw a blanket or a towel on top of it and add some insulation. So this gets up to 60C, that's like 140F. There's a lot of surface area at 140F, and you're going to dissipate a lot of heat that way. So in order for the machine to heat up faster and work a little less hard, theoretically you'll save a little energy in the process. Just throw some insulation on there, and I promise you you'll like it a lot more. Alright, last but not least, I got a couple demos for you. So I've got a bending coupon, one where I printed very hot and one where I printed fairly cold. I'm going to show you how much the Z strength changes when you do that. Alright, this is my DIY bending coupon tester. The outer white numbers on the dial is the force in pounds being applied by the air cylinder. This is a Hyper PLA CF coupon printed very hot with the Z orientation being from right to left. The key thing here is that the temperatures are very high, the flow rate is high, and there are 0 fans. So you can see we're getting pretty considerable force here, almost 45 pounds all the way up to, 45 pounds. Alright, now let's compare the stock settings on Hyper PLA CF. So the biggest difference here, flow ratio down to 0.95, chamber temp to ambient, nozzle down 10 degrees, model and side fan on, slower volumetric flow rate by roughly 20%. And now you can see you're getting half the strength. So moral of the story, print hot. Alright, so we got 2 blocks here, same block, it's been machined off so you can see the internals. Only difference is one of them is printed normally at a nominal 100% flow rate, whatever that might be, and then the other one is printed beyond 100% nominal. So if you look at the low flow rate version, look at all the voids you've got there in that wall. So those imperfections lead to failures, poor layer-to-layer bonding, and then the filament lines don't bond to each other very well either. Then if you look at the high flow version, you can see here you've got what looks like basically a solid surface. You can't even see a differentiation between the filament lines, and there are 0 imperfections or voids in there. Alright, here's how I keep my build plate in great condition and get every material I use to stick to it without using any sort of fancy adhesion methods. So just get a regular Elmer's glue stick, get it all lathered up in here, don't worry about getting it even at all. Then get a very wet paper towel, like dripping wet. Side note, these blue paper towels from Costco are awesome, you should definitely get them, they're called shop towels. Then take your paper towel, start rubbing this all over in a circular motion, and eventually this glue is going to turn into a little bit of a slurry here, just like it is right now. And now all those clumpy spots just get taken up into suspension in the liquid. And now just leave it like that, let it dry, turn the temperature on the build plate up if you want it to dry a little quicker, and now you're going to be left with a really nice, even, thin film of glue all the way across. All your prints will stick great and they'll pop right off. Alright, thanks for watching. If there's anything you guys want to see related to the videos I've done, please post them in the comments. Otherwise, I'm sure I'll come up with something cool soon, and I'll see you next time.